Welcome to compilersutra. In this video, we will show you how to detect your GPU using OpenCL in C++. Whether you are building a high-performance application, just exploring GPU computing, this tutorial is perfect place to start. In the previous video, we explored the theory behind GPU detection using OpenCL. In this video, we will demonstrate it practically by writing real code step by step. Want to read more? The link is in description. You can also visit compilersutra.com/gpu/OpenCL, where you can actually find the code. Step by step breakdown. Step 1. Here, what we do first. We first define OpenCL version. So what does it mean? Let's see. First we'll define OpenCL version. So we use macros CL target OpenCL version. Why? These macros limit the OpenCL API to version 2.0 features. It prevents accidental use of newer API and ensures forward compatibility across different hardware and SDK versions. So here argument 200 corresponds to the OpenCL version 2.0. This value ensures that functions from OpenCL 2.0 and earlier are available. Step 2. In step 2, we include the headers. Why? Let's see. The headers gives us to access to the OpenCL function and type relative to print to the terminal. Note, you can get the OpenCL headers by cloning from the links you are showing on the screen or from the description. Once you have these headers, then we have to move to the step 3. What the step 3 is about? The step 3 to talk about discovery of OpenCL platform. So here in this step, discovery of OpenCL platform, we use the API CL unit num platform clGetPlatform ID. Why this step is required? We must first check how OpenCL platforms are available on the system. Here argument 0, we are not returning platform ID yet, just querying how many are available. Second argument is null pointer. We are not providing buffer yet. And third argument, what does it mean? We want output variable to receive the number of platforms found. So the next step, let's move to the fourth step. So in step 4, what we do, we select the first platform. So here, let's see which API we use here. For the fourth step, selecting the platform, we use clGetPlatform ID. Why? Now that we know that how many platforms are available, we retrieve the first one. The number 1, the first argument, if you see, it's 1. What does it mean? That number of platform ID to retrieve. And second is the reference of the platform. What does it do? The variable to store the platform ID, and third one is null pointer. We don't need the actual number and return again. In step 5, what we are going to do, we will discover the GPU device under platform. For that purpose, let's see which API we will use. We will use the API clGetDeviceID. Why? This checks how many GPU devices are available under the selected platform. So here the argument platform tells that the platform from which to retrieve the device, clGetDeviceGPU, we are specifically looking for GPU device, and 0 means not fetching device yet, and null PTR no buffer yet, and num device store the number of GPU devices found. Let's move to the next step. The next step is select the first GPU device. For that purpose, let's see which API we are going to use. For selecting the first GPU device, we are going to use again clGetDeviceID. After confirming a GPU exists, we fetch actual device handler. So if you see the API, in that the argument 1 has input 1, which tells us the number of device ID to retrieve, and device reference tells that output variable where the device ID is stored. And step 7. In step 7, we query about the device info. What that does mean? So in step 7, querying device info means that we extract meaningful information like device name, vendor, memory size, and compute unit. The common argument device say that the selected device ID. The second argument specific what property to fetch, and third buffer size, and fourth buffer to hold the result, and fifth optional output of size of return data type. And what does this step? Next step, once we get the information about the device, next step is to print the information. So for that purpose, we use the cout APIs of the. We will use the cout object of the IOStream for printing the information. Why this step? This step format and prints the GPU information to the terminal. So the output field, device name, and vendor help you to identify the GPU, the memory, MB, so how many memories available, and compute units indicate processing code. So the next step is how to see how the code will look like. If we see the first 3 lines, they are mostly include directives. The first line, CL target version 200, tells that this is OpenCL version 2, and this header file cl/cl.h defines defines OpenCL data type and function. IOStream is used for console output. We need to find platform we have. This snippet basically tells us those things. OpenCL may have multiple platforms. This function clGetPlatformID calls get the number of available platforms without retrieving them. The first parameter is 0. It tells OpenCL not to return any actual platform ID in this call. The second point parameter is nullPTR. Since we don't need the ID yet, we don't provide a buffer. The third parameter, this receives the total count of available platforms. Then we move to the next step, that is get the first platform. The CR platform ID platform. This snippet basically we are using again here CR platform get ID. We are again using the function called CR platform get ID, but here instead of here we are getting the first platform. This is often enough for basic usage of GPU setup. The step 4 is querying number of GPU devices. This asks how many GPU devices are available on the selected platform. This is the discovery phase. We are not retrieving any device yet. The CL device type GPU to detect the GPU devices, and we can also pass here as per requirement CL device type or to detect any kind of OpenCL capable device. The step 5th will be finding any single GPU device from the selected platform. One means we want just one device. Device is where the OpenCL device ID is stored. This ID will be used to fetch device specific info for creating context and queues. Here we have defined buffers to store the device information. Then we are using the each call extract a specific hardware property. These are very fast furious calls. No kernel is launched. Use them to print info or select appropriate devices for your application. We are using CL device name, CL device vendor, CL device global memory size, CL device max compute unit. And then what we have done, we output the retrieved GPU detail to a terminal, which help us to confirm which GPU is currently running. So this is the basic needed to just get the GPU information which our OpenCL have. Let us assume you don't have any GPU, then how we will run it. In upcoming videos, we will see how to build this code and what to do if you don't have any GPU and where you can run it.